you do algebra, you're going to get an answer, and that answer is also in component form. But remember that vector components aren't the intuitive way to describe a vector. The intuitive way, the natural way to describe a vector is magnitude and direction form. So you want to give your answer in magnitude and direction form, which means we need to do another conversion. We need to convert back from components to magnitude and direction. This is the flow that vector problems are going to have. Information is going to be given in magnitude and direction form to do a problem. If you have vector A and vector B and your answer is A plus B, you need to first convert it into component before you can add the two vectors. If you say A plus B equals C, and C is your answer, you want to give the C in magnitude and direction form, so you need to convert it from components to magnitude and direction. That's the flow of almost every single vector problem. So we have to learn how to convert between these two forms. Any questions about that? Let me talk about why magnitude and direction is the more natural form, the more intuitive form. Another vector that we're going to see is velocity. Velocity is closely related to another quantity called speed. In everyday language, velocity and speed are used all the time, and they're used interchangeably. Okay? The problem is that these words have very, very specific meanings in physics. Physics uses a lot of everyday words. Distance, velocity, speed, force, energy, pressure, things like that, okay? And a lot of the times, your intuitive understanding of what the word means from everyday language is close to what it means in physics, but it's not exactly right. So we have to be very careful about how we use those words in the context of physics because they have very specific definitions, okay? So speed is just how fast an object moves. That's basically the everyday understanding. It's the number on a speedometer, okay? So if you hit the gas pedal and the needle on the speedometer rises to 35, that single number, 35 miles per hour, that one number, that scalar, that's your speed. It's how fast you're moving. You're moving 30 miles from where you start every hour. Velocity is how fast an object moves and the direction it moves in. So speed is a scalar. What type of information is velocity? Is velocity a scalar? No, what type? It's a vector. Not what form it's in, right? But it is a vector. Why is it a vector? Because it has 2 bits of information. It has how fast and the direction. So what would we call the magnitude of velocity? We call the magnitude of displacement, we call that distance. What would we call the magnitude of velocity?
Direction?
No, the speed. The magnitude is just how fast it's moving, which we call the speed. Okay? So sometimes for certain quantities, the magnitude will have a special name. For displacement, the magnitude has a special name of distance. For velocity, the magnitude has a special name of speed. Okay? But they are related to one another. Even though they're related, they're not quite the same. So let's imagine the velocity of a car. So what I'm going to choose now is a coordinate system that everybody would agree on. Like I said, a lot of times there's a natural coordinate system, and the natural coordinate system will be east, I'll call the x direction, and north, I'll call the y y direction. Okay? Everybody agrees where north is. It's where our compass points. Everybody agrees where east is. Okay? If we had a car that was traveling at 50 miles per hour as its speed at an angle of, hold on 1 second. I never remember these numbers off the top of my head. It's a particular, 53 degrees. You guys remember high school geometry well? You'll know why I chose 53 degrees. Okay? This is the 3, 4, 5 triangle. All right, but I can't remember 53 degrees off the top of my head. All right? This 53 degrees, we would give a special wording. We would say it's 53 degrees north of east. So you start by imagining going east, and then you move the arrow 53 degrees to the north of it. Okay? So this is 53 degrees to the north of east. Right? That is the velocity of that car. And it's given in magnitude and direction form because it makes sense to think about this car as moving in a single direction. The components of this velocity would be 30 miles per hour east and 40 miles per hour north. So you can say that the car is moving 50 miles an hour at 53 degrees north of east in a straight line, or you could say that the car is moving both at 40 miles an hour north and simultaneously at 30 miles an hour east. Does it make sense intuitively to say that the car is simultaneously moving 40 miles an hour north and 30 miles an hour east? Doesn't really make intuitive sense, right? You think about the car as moving in one direction. Does it really make intuitive sense to describe the car as moving simultaneously in two directions? No. Components are oftentimes not going to make intuitive sense, but they will make mathematical sense. All that those components tell you is that if you allowed the car to drive for 1 hour, so it starts here, and if you allowed the car to drive for 1 hour, it would end 40 miles north of where it started and 30 miles east of where it started. But that doesn't mean that it traveled in two directions simultaneously. Its actual path taken is the black line. It drove in a straight line like you would imagine. All that the components tell you is that after 1 hour, the car ends 40 miles north of where it started and 30 miles east of where it started. Okay? And if you use the Pythagorean theorem, because this forms a triangle, if you do 30 squared plus 40 squared, square rooted, you will get a distance of 50 miles from where it started. And if it was moving at 50 miles an hour, after 1 hour, you should expect it to travel 50 miles. So it will end 50 miles from where it started. So the math all makes sense at the end. The math works. But I'm telling you that the components don't make intuitive sense. It doesn't make intuitive sense to think about the car as moving both in the north direction and in the east direction at the same time. What makes intuitive sense is to think about the car moving in one direction. Plus the magnitude of that number, the total magnitude of that vector, that's what your speedometer reads. Your speedometer isn't going to spit out the components of your velocity. It's not going to tell you you're traveling 40 miles an hour north and 30 miles an hour east. Speedometer is going to give you one number, the total magnitude of that vector. It's not going to give you components. Okay? So magnitude and direction form is the intuitive form of vectors. but the component form is the mathematically useful form of vectors. So we're going to have to convert between the two. Any questions? Yeah. So let's do that right now. I'll give you a velocity in some direction, and we'll come up with the components of that velocity. So let's say that the velocity of a car is 35 miles per hour at 25 degrees west, south of east. Okay, let's start with this. I'll draw my coordinate system. Here's east in the x direction. Here's north in the y direction. Okay? The way, once again, you interpret this south of east is you imagine going east and then rotating the vector 25 degrees south. Okay? So the velocity points 25 degrees to the south of the east direction. And it's 35 miles per hour. Okay? The components are going to run along the x direction and the y direction. Technically, the y component is in the negative y direction, but we'll ignore that for now. So let me draw one component. Let's call that x. And let me draw another component, and I'll call that y. Okay? Notice that this forms a triangle. And the reason why you want to use perpendicular coordinates, because this question was asked, as opposed to one coordinate and another coordinate just at a random angle, the reason why you want to choose perpendicular coordinates is you want the components to be perpendicular so that this forms a right triangle. Now that this is a right triangle, you can do trigonometry on this triangle. Okay? So let me draw this triangle. This triangle has an x component right here. It has a y component right here. And it has a magnitude of 35 miles per hour. Okay? And then this interior angle right here is 25 degrees. Between the x component and the hypotenuse is 25 degrees. So we can find the components, the x component and the y component, we can find that by using a simple trigonometry. All you guys have to remember is SOHCAHTOA. All you guys have to remember is your definitions of the trig functions. That sine is the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. Okay? Just as a quick reminder, the hypotenuse is the longest edge of the triangle. See this one. Okay? The adjacent edge is the edge touching the angle. Which of these two edges, x or y, touches the angle 25 degrees? The x-axis, right? It touches it right here. This is adjacent to the angle. It's next to the angle. The opposite edge is the edge on the other side of the triangle from the angle. The y component is on the other side of the angle. So it's the opposite edge. So all we have to do is construct sine and cosine, and that will give us the components. So sine of 25 degrees is going to be the opposite edge, which is the y component, over the hypotenuse, which is 35. So how do I solve for y? Just multiply by 35. So y is just 35 sine of 25 degrees. You can do that on the calculator. 5 sine times 35 is 14.8. Don't forget to make sure your calculator is in degrees. So it's 14.8 miles per hour. That's the y component of the velocity. Construct cosine, and we can find the x component. Cosine of 25, cosine is adjacent over hypotenuse. The adjacent is the x component. The hypotenuse is once again 35. So how do we solve for the x? Just multiply the 35 up. So the x component is 35 cosine of 25 degrees. 31.7 miles per hour. And those are your components. So the velocity can be written as 35 miles per hour at 25 degrees south of east, or we can write the velocity as 31.7 miles per hour east, because it's moving to the east, and 14.8 miles per hour south. That's how you would write the velocity in components.